Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 1 video on the chapter of quadrilaterals, where I will discuss about the fundamental properties of the quadrilaterals, about their angles, sides and the angle sum property with some illustrative diagrams and examples. Uh, so this video is part of the playlist CBSE Maths 8 RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's start the part 1 video on the chapter of quadrilaterals. Okay, so I have prepared the rough notes that I will discuss about quadrilaterals, as you can see on the right hand side. In this video, I will not solve any problems. In the next video, I will solve the problems of the exercise 15A on the chapter of quadrilaterals from the textbook of author RS Aggarwal. So I have recently completed the chapter Polygons. So as you know that I hope you have watched all the videos on the chapter of Polygons, and as well as the 5 good problems from the other playlist Maths 8 Hot. So good understanding of polygons is essential to understand quadrilaterals. Now, what is the quadrilateral? Quadrilateral is a convex polygon having 4 sides. So it is a polygon, but the polygon has to be convex and it has 4 sides. So that is a definition of a quadrilateral. So as you can see, now if you are not familiar with the terms polygon and convex, in short I will say that what is a polygon? A polygon is a simple closed curve. A polygon is a simple closed curve and is formed by line segments, only line segments. There is no curve in a polygon. For example, this is a polygon, but this is not a polygon, and the polygon is a closed curve. That is, this is not a, for example, this is not a polygon because it is open. So a polygon is a simple closed curve, and what is meant by simple? By simple it means the polygon or the curve will not intersect with itself. This is a curve that intersects with itself at this point. So this is not a simple curve. So a polygon is a simple closed curve formed by only line segments. And what is a convex and concave polygon? What is a convex polygon? So a convex polygon is a polygon where all the interior angles are less than 180 degree. And so all interior angles are less than 180 degree. That is a convex polygon. And if at least one interior angle is greater than 180 degree, it becomes a concave polygon. So a quadrilateral is a convex polygon having 4 sides. Now, what are the essential parts of a quadrilateral? So a quadrilateral has 4 vertices, that is the corner points, or you can say the points at which 2 sides intersect. So it has 4 vertices, it has 4 sides, it has 4 angles, that is the interior angles, 4 interior angles. Now angles of a quadrilateral always means interior angles of the quadrilateral, and it has 2 diagonals. We will see in more details about the vertices, sides, angles, diagonals of a quadrilateral. Now some examples of quadrilaterals. I have drawn 3 examples. As you can see, let's try to see what are the vertices, angles, sides and diagonals of these quadrilaterals. So the quadrilateral, the first one, ABCD, in this quadrilateral, the vertices, as you can, I hope you can easily say or understand what are the vertices, that is the corner points. So these points, these 4 corner points where 2 sides intersect, these are the vertices of the quadrilateral. So for the first quadrilateral, the vertices are A, B. The vertices are always denoted by capital letters. Always capital letters, and whenever you name the vertices of a polygon in general, always use capital letters and letters in order, sequentially, like A B C D E, like A B C D for a quadrilateral. If it is a pentagon, then A B C D E. If it is a hexagon, A B C D E F. You should never name a polygon, name the vertices of a polygon using mixed letters, like this is a polygon, this is a pentagon. As you can see, it has 5 sides. Never name a pentagon or a polygon like this, like X Y Z and then AB. No, I mean, you can, but the convention is always to give letters in sequential order and use capital letters. So this is a wrong naming. Okay. So for the first quadrilateral, the vertices are ABCD. What are the angles? These are the angles. That is, so that is the angle made by two sides which have a common point. So as you can see, okay, let me. So what are the sides? What are the sides of the first quadrilateral? AB, BC, CD, and DA. These are the 4 sides of the quadrilateral. What are the angles? The angles are basically named after the vertices. That is, the four you have 4 angles in a quadrilateral, 4 interior angles, and each interior angle is created by two adjacent sides. So in this quadrilateral, the angles are angle A, angle B. They are basically named after the vertices. So this angle, this is the angle A, or more appropriately you can say angle DAB or BAD. So this is the angle D, or you can say this is also, you can name it as angle ADC or CDA. This is angle C. You can also name it as angle DCB or angle BCD, and this is the angle B. Okay, now what are the diagonals? The diagonals are, what is the diagonal of a quadrilateral? If you connect the line segment joining two opposite vertices. Now, actually, I will discuss more about what are adjacent sides, opposite vertices a little later on. But let me quickly draw what are the vertices. So DB or BD, anyway you can name it. This is one diagonal, and another diagonal is AC. This is another diagonal. Okay. So AC and DB are the 2 diagonals of this quadrilateral. Let's see for the second quadrilateral, what are the vertices? Obviously, the vertices are the corner points, that is PQ, R and S. What are the sides? PQ, QR, RS and SP. And what are the angles? This is the angle P. Obviously, it will name, the angles are named by convention by the vertices PQ, R and S. So this is the angle P, this is the angle Q, this is the angle R, and this is the angle S. Okay. Now what are the diagonals? The diagonals are PR and SQ. So this is PR joining the P and R are 2 opposite vertices. So one diagonal is PR, and S and Q are other 2 opposite vertices. If I join S and Q, the line segment formed is another diagonal. So PR and SQ are the 2 diagonals. A quadrilateral always have 2 diagonal. For the last figure, which essentially is looking like a rectangle or square. Anyway, let's say this is a square. So the vertices are W, X, Y, Z. Always please note that I have named all the quadrilaterals in sequential order of capital letters. Okay. What are the sides? WX, XY, YZ, and ZW. And what are the angles? W, X, Y, and Z. So assuming, let's say this is a square, so this will be right angles. All the corner angles or the interior angles of a square are all each 90 degree. So we have this, and what are the diagonals? If one diagonal is connecting the two opposite vertices W and Y, so WY, and the other diagonal is connecting the two other opposite vertices Z and X. So Z and X. So this is ZX and this is WY. Okay. So this is an overall view of what is a structure of a quadrilateral, that is having four sides, four angles, there are four interior angles, two diagonals. Okay. Now let's discuss about the angles, sides, and the diagonals and vertices in more details. Okay. So what are opposite vertices of a quadrilateral? So the definition says that any two vertices that are endpoints of different sides. Any two vertices in a quadrilateral, if you take any two vertices, and if those two vertices lie on different, if those two vertices are endpoints of different sides, as you can see, this side AB has endpoints A and D. This side's AB, the side AB has endpoints A and B. The side BC has endpoints B and C, and the side CD has endpoints C and D. Now, if you take two vertices that are not endpoints of the that are endpoints of different sides. If you consider the vertex A, now vertex A is endpoint of the side AD and AB. So definitely vertex A cannot be an opposite vertex to D and B. Vertex A has to be opposite to C, because because C is the only vertex which is an endpoint of the sides CD and BC, and so which are different from the sides AD and AB. I hope you're understanding. So for this quadrilateral, the opposite vertices are so there are always two set of opposite vertices. One set of opposite vertices are A and C. A and C are opposite vertices, and the other set of opposite vertices are D and B. Since the endpoints, the vertices A and C, they are endpoints of different sides. Vertex A is endpoint of the sides AD and AB, whereas the vertex C is endpoint of the side CD and BC. Similarly, the vertex D is endpoint of the side AD and DC. So this vertex A is endpoint of AD and AB, whereas vertex C is endpoint of side CD and CB. So they are endpoint of different sides, so they are opposite vertices. Similarly, the vertex D is endpoint of side AD and DC, and the vertex B is endpoint of AB and BC. So they are endpoint of different sides. So AC, A and C are opposite vertices, and also D and B are opposite vertices. Okay, I hope you understand by now what is meant by opposite vertices of a quadrilateral. So now quickly write down what are the opposite vertices of the other two quadrilaterals. So PQRS in this quadrilateral, the one set of opposite vertices are P and R, and the other set of opposite vertices are Q and S. For the third quadrilateral, that is WXYZ, the first set of opposite vertices are W and Y. The other set of opposite vertices is X and Z. So this is about opposite vertices of a quadrilateral. Okay. Now let's see what is opposite sides of a quadrilateral. What do we mean by opposite sides of a quadrilateral? There are four sides of a quadrilateral, and there are two set of opposite sides of a quadrilateral. Let's understand. Now what is the definition says? Any two sides that do not have a common vertex, they are known as opposite sides. Let's take in the first quadrilateral, let's take the side AD. Now any other side will be an opposite side to AD if that side do not have a common endpoint with the side AD. Now the side AD has the endpoints A and D. Now DC cannot be the side DC cannot be an opposite side to AD because DC also contains okay, let's quickly write down what are the endpoints of the sides. So DC endpoints is obviously D and C, and BC, for the side BC the endpoints are B and C, and the side AB the endpoints are A and B. Now if you consider one side AD, what will be the opposite side of the side AD? Any side that do not have a common endpoints with the AD, the endpoints of AD is A and D. You have to consider any other side which do not have either A and D as its endpoint, and that side is only BC. That side is only BC because BC has endpoints B and C which are completely different from the endpoints A and D. So the opposite side of AD is BC, and obviously the remaining other two sides are opposite sides. That is AB and DC are also opposite sides. So in a quadrilateral there are two set of opposite sides. So the first set of opposite sides we can say is AD and BC. The other set of opposite sides is AB, or not set. I think it's better to say a pair of opposite side. AD and BC is the first pair of opposite sides, and AB and DC is the second pair of opposite sides. Similarly, you should consider pair of opposite vertices. I was saying set, but set is the incorrect way of saying opposite. A pair of opposite vertices. For the first quadrilateral ABCD, A and C is a pair of opposite vertices, and D and B is another pair of opposite vertices. Okay. I hope it is clear what do we mean by a pair of opposite sides of a quadrilateral. Now let's quickly write the pair of opposite sides of the other two quadrilaterals. For the quadrilateral PQRS, the first pair of opposite sides will be PQ and RS. The second pair of opposite sides will be PS and QR. Okay. Let me use some symbols. Now in the first quadrilateral, I have given single stroke to the sides AD and BC to mean that the sides AD and BC is a pair of opposite sides. Similarly, I have marked two strokes on the sides AB and DC to mean that the sides AB and DC is a pair of opposite sides. Okay. So we have this and we have this. Okay. Now for the third quadrilateral, the first pair of opposite sides will be WX ZY, WX ZY, and the other pair of opposite sides will be XY and WZ. So XY and ZW. It does not matter if you name it WZ or ZW, it means the same thing, same side. Okay, so this is a pair of opposite sides of a quadrilateral. Okay. Now let's see what are What is a pair of adjacent sides of a quadrilateral? What do we mean by a pair of adjacent sides of a quadrilateral? The definition says that any two sides that have a common vertex. Any two sides of a quadrilateral that have a common vertex or common endpoint. You can see, if you consider, so how many pair of adjacent sides are there? There are four pairs of adjacent sides, because there are four vertices of a quadrilateral, and you can see and you can understand that every vertex is a common endpoint to two sides. Vertex A is a common endpoint to the sides AD and AB. Hence, the side AD and AB will be a pair of adjacent sides. Similarly, for every vertex, you will find that every vertex is a common endpoint to two sides. And since there are four vertices, obviously there will be four pairs of adjacent sides. Okay. Now, if I try to visually mark adjacent sides on the quadrilateral, it will be a mess. So I'm not doing anything on the diagrams. I'm directly writing the pairs of adjacent sides. So the first pair of adjacent sides for the first quadrilateral, that is ABCD, if I consider the vertex A, considering the vertex a pair of adjacent sides will be AD and AB. These two sides, AD and AB, are pair of adjacent sides, as they have the common endpoint A or the common vertex A. Okay, now if I consider the vertex B as it is a common endpoint to the sides AB and BC. So AB and BC is another pair of adjacent sides. Similarly, if I consider the vertex C, it is a common endpoint of the sides CD and BC. So therefore, BC and CD is another pair of adjacent sides. And finally, if I consider the vertex D as a common endpoint, so vertex D is common endpoint to the sides AD and DC. So we can say that AD and DC is another pair of adjacent sides. Let's quickly write down the adjacent sides for the other two quadrilaterals. For the quadrilateral PQRS, the first pair of considering the vertex P, the adjacent sides will be PS and PQ. Considering the vertex Q, the adjacent sides will be PQ and QR. Considering the vertex R, the adjacent sides will be QR and RS. And considering the vertex S, the adjacent sides will be RS and SP. Okay. For the last quadrilateral, that is WXYZ, considering the vertex W, the adjacent of the pair of adjacent sides will be ZW and WX. Considering the vertex X, the pair of adjacent sides will be WX and XY. Considering the vertex Y, the adjacent sides will be XY and YZ. And finally, considering the vertex Z, the adjacent sides will be ZW and YZ. So this was a pair of adjacent sides of a quadrilateral, and there are four pairs of adjacent sides in a quadrilateral. Okay. Next is adjacent angles of a quadrilateral, that is a pair of adjacent angles of a quadrilateral. It is quite similar to adjacent sides, but related to the interior angles of a quadrilateral. Now, when do we say that two angles in a quadrilateral are adjacent? The definition says that any two angles that have a common arm. Now, common arm or side. So, these are the four sides of the quadrilateral ABCD. Now, if you consider the angle A the angle A, this angle A has two arms, basically two sides or two arms. I mean, technically, an arm has an angle is formed by two arms that meet at a common point or have a common vertex. So an angle is made by, if this is the angle, this AB, let's say AO and OA and OB are the two arms of the angle AOB, and the two arms OA and OB are meeting or intersecting at the common point or having a common point O. So this is the definition of an angle. So for the quadrilateral ABCD, the angle A is made up of two arms, AD and DB, AD and AB. Now, what is another angle? What is any other angle that has a common arm with the angle A? If you consider angle B, then angle B also has two arms, AB and BC. So angle A and angle B are having the common arm AB. So angle A and angle B are adjacent angles. But see, if you consider the angle A and angle C, the angle C, the arms of the angle C are the DC and BC, whereas the arms of the angle A are AD and AB. So AD and AB are completely different from CD and BC. That is, there is no common arm. Of the arms between angle A and C. So angle A and angle C are not adjacent angles. So also you will see that angle A and D, they are angle A and angle D, they also have the common arm AD. So I hope you can understand what are two adjacent angles. So basically, if you consider a side, every side of a quadrilateral has two endpoints, and those two endpoints are nothing but the vertices of the quadrilateral. And we know that all the interior angles are named by after the vertices of the quadrilateral. So the two endpoints of any side, they are adjacent angles. As simple as that. If you consider any side, it has two endpoints. If you consider side BC, it has two endpoints, that is the vertices C and B. So angle C and B are adjacent angles. Similarly, if you consider the side AB, it has the side AB has two endpoints, the vertex A and B. Therefore, the angles A and B are adjacent angles. Okay. So as you can see, since there are four sides, there will be four pairs of adjacent angles. Now, if I consider, I am writing down the adjacent angles for the quadrilateral ABCD. So if I consider the side AB, it has two endpoints A and B. So a pair of adjacent angles will be angle A and angle B. If I consider the side BC, it has two endpoints B and C. So the pair of adjacent angles will be angle B and angle C. Similarly, if I consider the side DC or CD, it has two endpoints D and C. So angle C and angle D are pair of adjacent angles. And finally, if I consider the side AD, it has two endpoints A and D. So angle A and angle D are pair of adjacent angles. I hope it is clear what do we mean by a pair of adjacent angles in a quadrilateral. Now let's quickly write down the pair of adjacent angles for the other two quadrilateral. For the quadrilateral PQRS, if I consider the side PQ, the pair of adjacent angles will be P and Q. If I consider the side QR, the pair of adjacent angles will be Q and R. If I consider the side RS, the pair of adjacent angles will be R and S. And if I consider the side PS, the pair of adjacent angles will be P and S. Okay. Okay. So So for the quadrilateral WXYZ, if I consider the side WX, we get a pair of adjacent angles as angle W and angle X. If I consider the side XY, the pair of we get another pair of adjacent angles, that is angle X and angle Y. If I consider the side ZW, we get the pair of adjacent angles, angle Z and angle Y. And if I consider the side WZ, the pair of adjacent angles will be angle W and angle Z. Okay, so let me quickly visually show the adjacent angles of the quadrilateral WXYZ. So these two are adjacent angles. Again, these two are adjacent angles. Again, these two are adjacent angles, and finally these two are adjacent angles. Okay, so this was a pair of adjacent angles in a quadrilateral, and a quadrilateral has 4 pairs of adjacent angles. Okay, next is a pair of opposite angles of a quadrilateral. It is similar to a pair of opposite vertices of a quadrilateral. Now it is you know what is a pair of opposite vertices of a quadrilateral, and those two vertices and the angles, we also know that a vertex is an interior angle of a quadrilateral is named after the vertex. So this interior angle will be named after the vertex A, since the angle is formed, the common point of the arms of this angle is A. Okay, and we know that vertex A and C, vertices A and C are opposite vertices. So therefore, angle A and angle C will also be opposite angles. So you can understand this way: two opposite vertices makes a pair of opposite angles. Okay, so for the quadrilateral ABCD, and as you know that there are 2 pairs of opposite vertices, so definitely we will also have 2 pairs of opposite angles in a quadrilateral. So for the quadrilateral ABCD, the one pair of opposite angles are angle A and angle C, and the other pair of opposite angles are angle B and angle D. For the quadrilateral PQRS, so angle A and C are opposite angles, and angle D and angle B are opposite angles. Now please do not confuse with the double stroke. Now if 2 angles are marked with a double stroke, usually it means they have the same measure, but I am not trying to mean that. I am just trying to visually mark a pair of opposite angles. When I am marking the angle D and B with double stroke, I mean to say that they are opposite angles. Similarly, and I have marked the angles A and C with single stroke to mean that they are opposite angles. Okay. For the second quadrilateral, the opposite angles will be angle P and R are opposite angles, and angle S and Q are opposite angles. So angle P and angle R is one pair of opposite angles, and angle S and angle Q is another pair of opposite angles. For the quadrilateral WXYZ, W and Y is a pair of opposite angles, and X and Z is another pair of opposite angles. So W and Y, this is one pair of opposite angles, and angle X and angle Z is another pair of opposite angles. So this was a pair of opposite angles in a quadrilateral. A quadrilateral has 2 pairs of opposite angles. Okay. The next one is about diagonals of a quadrilateral. Now a diagonal is formed by joining two opposite vertices of a quadrilateral. Since we know there are two pairs of opposite vertices in a quadrilateral, obviously a quadrilateral will have two diagonals. One diagonal is formed by joining two opposite vertices of a quadrilateral. So this is and also we have studied in the chapter of polygons that a polygon having n sides, the number of diagonals is n into n minus 3 whole divided by 2. So we know that a quadrilateral is a polygon having 4 sides. So if we substitute 4 as n in the formula is n for a polygon having n sides, the number of diagonals is n into n minus 3 divided by 2. For a quadrilateral, n will be 4. So the number of diagonals from the formula also we can see it will be 4 into 4 minus 3 whole divided by 2, which is equal to 2. So that was based on the formula, and based on the geometry of a quadrilateral, we can see that a diagonal is a line segment that joins a line segment that is formed by joining two opposite vertices of a quadrilateral. And since there are two pairs of opposite vertices in a quadrilateral, obviously a quadrilateral will have two diagonals. Now let's quickly see what are the diagonals of these three quadrilaterals. So first, obviously, as you can see, D and B are opposite vertices. So for this quadrilateral ABCD, opposite vertices are one is A and C, and the other one is D and B. So obviously A and C will make one diagonal, that is AC, and the vertices D and B will make another diagonal, that is DB. Okay. For the second quadrilateral PQRS, the opposite vertices are PR is one pair of opposite angles, and the other pair of opposite angles is Q and S. So obviously the vertices P and R will make one diagonal, that is PR, and the other vertices S and Q will make another diagonal, that is QS. For the third quadrilateral, the opposite vertices are WY and XZ. So the WY opposite vertices will make one diagonal, that is WY, and the other pair of opposite vertices X and Z will make the other diagonal, that is XZ. So we have XZ, this is WY. In the other quadrilaterals, we have the diagonals AC, this is AC, this is the diagonal DB or BD. We have in the second quadrilateral, PR is one diagonal, and the other diagonal is QS or SQ. Okay, so this was diagonals of a quadrilateral. Quadrilateral has two diagonals. Okay, the last one is angle sum property of a quadrilateral. Now you know that from the concept of polygon that now remember that a quadrilateral, remember that we know that for a convex polygon of n sides, a convex polygon having n sides, the sum of the interior angles is equal to, we know, convex polygon, convex n-sided polygon, we know that sum of interior angles is equal to 180 degree multiplied by n minus 2, where n is the number of sides of the convex polygon. We know this. Now, and quadrilateral is nothing but a four-sided convex polygon. So if we substitute 4 as n, we will get 180 multiplied by 4 minus 2, that is 180 multiplied by 2, that is 360. So the sum of the interior angles of a quadrilateral is always 360 degree. So as you can see in this illustrative diagram of a quadrilateral ABCD, we will have P degree plus Q degree plus R degree plus S degree is equal to 1 is equal to 360 degree. So this is angle sum property of a quadrilateral that says the sum of the angles of a quadrilateral, which essentially means the sum of the interior angles of a quadrilateral, is always 360 degree. So that is all regarding the theoretical concepts, and there is no as such formula, but these are all theoretical concepts of a quadrilateral. In the next video, I will solve, based on these concepts, I will solve the exercise 15A from the textbook of author RS Aggarwal. And the next chapter is parallelograms. Now, once I think there is two exercise. Let me check quickly. In the chapter of quadrilaterals, I think there is one exercise 15. There is only one exercise 15. Oh, there is only one exercise 15 in the chapter of quadrilaterals in the textbook of author RS Aggarwal. So I will solve exercise 15, all the problems, in the next video, and then I will try to parallelly prepare and solve 5 good problems on the chapter of quadrilaterals based on all the concepts that I have discussed in this video. So also keep an eye on the other playlist, that is Maths 8 Hot. So that is all for this video regarding the concept of quadrilateral. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.